Hello. In this review, we'll talk about the Indian light multirole fighter jet, Tejas. Initially, when it was just being planned, it could be classified as a third-generation fighter. The basic Tejas Mk.1 version and the Tejas Mk.1A version already belong to the fourth generation, while the Mk.2 version can be considered a 4+ generation fighter. In this review, I'll cover the development history of this aircraft, the different versions that have been created, their distinctions, and their capabilities. Before we begin, don't forget to subscribe to the channel and click like. It helps make our content better. Let's burn. Back in the early 1980s, India began to seriously consider the need to develop its own fighter jet. There were two major driving ambitions behind this. First, to arm itself with something more modern than the aging MiG-21. Second, to break away from Soviet-made equipment and prove that the country had the capability and engineering talent to create a fighter jet on its own, one that could rival both Soviet and European aircraft. Their own ideas, their own components, their own development. And this last part turned out to be a double-edged sword for the entire project. Another important factor, of course, was the ongoing rivalry with China and Pakistan. India needed to boost both the quantity and quality of its air force in order to have the upper hand in the event of a full-scale conflict. In 1983, the project officially began under the name LCA, Light Combat Aircraft. The original plan was to spend around 20 years on development, up until the moment it would enter service. In 1984, a special agency was created to lead the aviation development effort. It was called ADA, Aeronautical Development Agency. The responsibility for actually building the new fighter was assigned to HAL, Hindustan Aeronautics Limited. That's why you'll sometimes see the jet referred to as the HAL Tejas or LCA Tejas. Both ADA and HAL are part of India's State Defence Enterprise, DRDO. The task HAL was given was extremely ambitious, to ensure that around 70% of the jet's components would be developed and manufactured within India. The idea was to minimize dependence on international suppliers and build a multirole light fighter capable of hitting both air and ground targets, while also holding its own in dogfights against Chinese jets. And of course, by extension, to be competitive with Soviet ones too. The technical requirements were finalized in 1985. But after taking a hard look at them, it became obvious, India simply didn't have the necessary technologies at that point to build a fighter jet from scratch that met all those expectations. They lacked the experience to design the right airframe, wings made from advanced alloys and materials, and the overall structure that would be light and radar resistant. India didn't have its own turbojet engine with the right thrust-to-weight ratio. They didn't know what kind of avionics to use, they didn't have a radar of their own, the list goes on. If they tried to develop all of this from scratch, even 20 years wouldn't have been enough, not even in theory. So, they turned to partners. HAL signed a deal with French company Dassault Aviation to collaborate on the overall airframe design. And if you look closely at the Mirage 2000 and the Tejas, you'll notice some clear similarities. Both are built using a tailless delta wing configuration, that's thanks to the French. Both are single-engine jets with a similar rear section layout. In short, Dassault Aviation brought a lot of their own design philosophy and expertise into the future Indian fighter. By 1988, the sketch design of the future aircraft was complete, and it became clearer what exactly the jet would need. While the French company could help with the design of the fuselage and wings, there were still three key components that raised serious questions: the engine, the avionics, and the radar system. India set an ambitious goal to develop all three components domestically. The Gas Turbine Research Establishment, another organization under the DRDO umbrella, was assigned the task of creating a suitable turbojet engine. The project began that same year, and the engine was designated GTX-35 VS Cavalry, commonly referred to as simply Cavalry. However, the Cavalry engine would ultimately never be used in the Tejas fighter. In fact, the entire project was officially scrapped in 2014. It turned out to be a failure, more on that later. As for the radar, a system named MMR, multi-mode radar, was set in motion. The name says it all. The goal was to develop India's first fully indigenous airborne monopulse Doppler radar. The development was handled by several companies including HAL, LRDE, also part of DRDO, Hyderabad-based firms, and a few others. The radar's antenna weighed just 5 kilograms, and it could track up to 10 targets simultaneously, including fighter jets, and detect them at a maximum range of about 100 kilometers. It was designed to track both aerial and ground targets, but by 2005, the MMR radar was scrapped. It had performed poorly during testing and simply didn't meet the requirements for the new fighter. And most importantly, there was no money to fix or upgrade it. The same fate awaited the engine. Its development was repeatedly delayed due to lack of funding. In 1990, funding was finally allocated for the technical design of the new aircraft, along with initial development of its key systems. Two of them we've already talked about, the engine and the radar. The third major component came into focus in 1992, when HAL decided that the new aircraft would require a fly-by-wire control system. Since the aircraft's design was inherently unstable and unpredictable in flight, a digital flight control system was deemed essential. India had two options: either reach out to France, where such systems were already in use, or turn to the United States. Dassault Aviation had some experience with analog flight control systems, but India wanted a fully digital fly-by-wire system. And it was Lockheed, which just a few years later would become Lockheed Martin, that had the expertise. So in 1993, India signed a contract with the American company to develop this system specifically for the LCA project. The contract was worth $40 million, not a small sum by any means. But this part of the Tejas story would also end on a sour note. In 1998, India conducted a series of nuclear tests. And with that, the global political climate changed overnight. Many sarcastically say that 1998 was the year India became a nuclear power, and that did not sit well with the Europeans, and especially the Americans. The US government banned its companies from participating in any Indian defense projects. Lockheed Martin pulled out of the deal, taking the money with them. India was left to continue the development of the flight control system on its own. Originally, the 20-year timeline set for the LCA program implied that the aircraft would reach operational readiness and enter service by 2003. But by the late 90s, considering all the previously mentioned setbacks, it became clear that this deadline would be pushed back by at least a decade. In the best-case scenario, the fighter might be ready by 2012, or even later. By that point, India had already spent $1.4 billion on the project, a huge sum for the country at the time. And there was still a long road ahead. It was estimated that if the aircraft did become operational by 2012, the total project cost would come to around $2.3 billion. India's plan had originally looked like this. By 1988, complete the design sketch. In 1990, begin full-scale development. Finish this stage by 1994, then move on to building prototypes. By 1998, 2 LCA demonstrators would be joined by 2 more prototypes, ready for flight testing. But those plans were derailed by India's economic struggles in the 1990s, and then the international sanctions imposed after the 1998 nuclear tests, which lasted until 2001. Yes, in 1996, 2 technology demonstrators were built, equipped with American General Electric F-404 F-2J3 engines. For radar, they used Israeli pod-mounted systems that featured synthetic aperture radar technology. That same year, India also tested its own Kaveri engine for the first time, but it was clear that it wouldn't be ready or reliable enough for use by 2012. Despite that, they had hoped to install the Kaveri on 5 pre-production aircraft for testing, which of course, never happened. In 1998, they began building 2 full prototypes and started testing the fly-by-wire flight control system, which HAL was refining in collaboration with several local companies. Due to all these delays and challenges, it wasn't until 2001 that the first demonstrator finally took to the skies. It was designated TD-1. A year later, in 2002, the second demonstrator, TD-2, also flew. Both had their issues, especially with weight. The aircraft needed to be lighter. So for the first real prototype, designated PV-1, they addressed this by integrating composite materials, which helped cut the aircraft's weight by around 500 kilograms. Another weak point was the flight control system. It also had to be refined. And the weapons control system needed major work too, since India wanted to integrate not only its own missile systems, but also Russian and European ones. One more thing that required improvement was the head-up display. The plan was to build 5 prototypes. The first, PV-1, flew in 2003, and the second, PV-2, only took off in 2005. There were high hopes that PV-2 would be much closer to the final version India had envisioned, but unfortunately, that wasn't the case. In 2003, a contract was signed to build 8 pre-production aircraft. The plan was for the first 2 to be ready by 2009, and for all 8 to take to the skies by 2012. That same year, an agreement was also signed with HAL to build 2 naval prototypes for the Indian Navy, 1 single-seater and 1 twin-seater. And now it's important to clarify the engine situation for this aircraft. Only the 2 early demonstrators, TD1 and TD2, were equipped with the General Electric F404F2J3 engine. Starting with the PV1 prototype and continuing through to the more advanced Tejas Mk.1A, all aircraft have been powered by the General Electric F404GEIN-20 turbofan engine. In 2004, the Aeronautical Development Agency signed a contract with General Electric for the delivery of 37 engines to power both prototypes and pre-production aircraft. These were scheduled to be delivered by 2008. India had by then realized that waiting for its own cavalry engine would lead nowhere. In fact, in 2005, even DRDO signed a contract with French company SNECMA to get a technical evaluation and to accelerate the cavalry program. Though this too would ultimately prove unsuccessful. Another major challenge was the radar. The Indian-developed radar didn't meet the required standards, in terms of target detection range, for both air and ground targets, and also in terms of the number of targets it could track simultaneously. So a replacement was clearly needed, and it would come later. The year 2003 was significant not only because of the many contracts aimed at speeding up development, but also because this was the year the new light multirole fighter received its official name, Tejas. In 2006, India's Ministry of Defense signed a $450 million contract with HAL for the production of 20 serial production Tejas jets, 16 single-seaters and 4 twin-seaters. This was despite the fact that the aircraft was still far from being ready for operational deployment. As for the engine, that question was resolved. The American F404GEIN-20 was chosen, as it met the aircraft's weight, size, and thrust requirements. But 2 key components were still in question. On the early pre-production aircraft, India used the Swedish Ericsson Ferranti PS05A radar, the same radar used on the Swedish Gripen. But when it came time for full-scale production, this radar was replaced with the ELTA LM2032, a pulse Doppler multimode radar with a slotted planar array antenna. To make that happen, India signed an agreement with Israel's ELTA Systems. After 2001, India managed to bring Lockheed Martin back into the project, which finally made it possible to install a digital fly-by-wire flight control system on the aircraft. Despite India's intention to make everything domestically, over 70% of Tejas components ended up being of foreign origin. During testing of the 5 prototypes, many issues were identified, including system compatibility, weight problems, and limitations in combat performance. Only in 2011 did HAL announce that Tejas had achieved initial operational clearance. But when the aircraft was presented to senior officials, they were very dissatisfied and deemed the declaration premature. The aircraft was sent back for further refinements, which took another 2 years. An improved version was presented in 2013, and it was then officially announced that Tejas had achieved initial operational clearance. As for the first serial production fighter, which had been ordered back in 2006, it first flew only in 2015. And here's where things get tricky. There's debate over which year should be considered the true start of its service. In 2015, Tejas was officially handed over to the Indian Air Force. But it didn't achieve full operational capability after all flight testing and final modifications until 2019. In 2010, India's Ministry of Defense signed another agreement with HAL for an additional 20 Tejas aircraft, bringing the total order to 40 jets. All 40 have since been delivered to the Indian Air Force. In 2017, a contract was signed for HAL to increase production of Tejas from 8 to 16 aircraft per year. By 2020, HAL had expanded its production capacity even further, and it can now manufacture between 16 to 24 aircraft annually, mainly focusing on the upgraded Tejas Mk.1A version, which we'll talk about in a dedicated section later. To wrap up this history section, one more important note. When India finally committed to the General Electric F404GEIN-20 engine in 2004, HAL initially ordered 37 engines, and later placed another order for 28, totaling 65 engines for the Tejas Mk.1 program. These engines were used in pre-production and serial production aircraft, along with spares for future replacement. However, due to low global demand, General Electric stopped producing the F404GEIN-20. For about 5 years, the engine was completely out of production, until India returned with a new request, prompting a restart of the production line. So that's the complex and bumpy story behind the Tejas fighter jet. And now, let's take a closer look at the base version in more detail. Tejas is one of the lightest aircraft in its class. Its empty weight is approximately 5,500 kilograms, and the normal takeoff weight is 8,500 kilograms. The internal fuel tanks can carry up to 3,000 kilograms of fuel. The maximum takeoff weight is 13,500 kilograms. The aircraft measures 13.2 meters in length, 4.4 meters in height, and has a wingspan of 8.2 meters. Many structural components are made of composite materials, which help keep it light. The Tejas features a tailless delta wing design with a high-mounted triangular wing. The fuselage has a semi-monocoque construction, with air intakes located on either side of the fuselage. It is a single-seat fighter. The two-seat version is used for training. In that version, the rear fuel tank is replaced by a second cockpit. The ejection seat used is the Martin Baker Mark 10L. Tejas is powered by a single General Electric F404GE in 20 turbojet engine, producing a thrust of 8,565 kg force. The aircraft can reach a maximum speed of Mach 1.6, which is about 1,960 km per hour, and can operate at altitudes up to 15,849 meters. Its combat radius is about 500 kilometers, and its ferry range, with external fuel tanks, is up to 3,000 kilometers. The fighter can withstand G loads of up to 9 G. Tejas is equipped with a quadruplex digital fly-by-wire flight control system. The control stick is positioned in front of the pilot, and the cockpit includes several multifunction displays to present flight and mission data. A head-up display is also installed. The aircraft has 7 hardpoints, 3 under each wing and 1 under the fuselage. It can carry up to 5 external fuel tanks, with a capacity of either 800 liters or 1,200 liters. There is also a retractable probe for aerial refueling located in the nose section. Behind the nose cone is the antenna for the ELTA LM2032 radar, a multi-mode pulse Doppler radar with a slotted planar array. It can detect targets like the F-16 at ranges of up to 150 kilometers. For navigation, Tejas is equipped with the Sagem Sigma 95N ring laser gyroscope-based inertial navigation system, supplemented by GPS. It also carries a 23mm twin-barrel GSH-23 cannon with a 220-round magazine. Its external hardpoints can be fitted with a variety of air-to-air, air-to-ground missiles, and bombs. The aircraft can also carry electronic warfare pods and targeting pods. Among the weapons Tejas can deploy are air-to-air missiles Magic, R-60, R-73, air-to-surface missiles KH-59, BrahMos, the Rudram anti-radiation missile, the French Hammer guided bomb and unguided free-fall bombs. A major goal was to integrate beyond visual range missile capabilities, but that required significant upgrades to the aircraft systems. Even before Tejas achieved full combat readiness, India began planning its modernization. It was clear that the aircraft was still far from the version originally envisioned. There was also a critical dependence on Western components, which India aimed to reduce. This led to the development of a second version, the Tejas Mk.1A. Externally, the Mk.1A looks identical to the base version, but it features significant internal upgrades. Collaboration with Israel's ELTA systems continued, resulting in the integration of an advanced radar, the ELTA LM2052 Active Electronically Scanned Array Radar. This allowed for longer-range target detection and the use of longer-range missiles. India specifically wanted to integrate the MBDA Meteor Beyond Visual Range Air-to-Air missile with the Tejas. However, the LM2032 radar on the base version couldn't fully support such long-range missiles, making an upgrade essential. The LM2052 radar can reportedly detect airborne targets at ranges of 150 to 200 kilometers, detect ground targets at ranges of up to 290 kilometers, track up to 64 targets simultaneously. With this radar, beyond visual range engagements became a practical reality. In 2025, India successfully test-fired the Astra air-to-air missile from the Mk.1 version. Astra has a range of over 100 kilometers and is India's own beyond visual range missile. In parallel, HAL began development of a domestic active electronically scanned array radar, UTOM, intended for the Tejas Mk.1A. In 2021, a contract was signed for the supply of 83 Tejas Mk.1A aircraft, including 10 two-seat trainers. Starting from the 41st production aircraft, these jets will be equipped with the UTOM radar, which can detect air targets at distances up to 140 kilometers. Under extended cooperation with Elta Systems and its parent company Israel Aerospace Industries, the Mk.1A was also fitted with an improved electronic warfare system, LL8222. Avionics were significantly upgraded as well. However, the engine remained a major bottleneck. In 2021, HAL signed a deal with General Electric for 99 F404GE in 20 engines, the same model used in the base version. But since General Electric had stopped production in 2016, restarting the assembly line proved to be a complex task. This delay, combined with performance shortfalls of the upgraded aircraft, shifted the entire delivery timeline. The first engine was finally delivered in March 2025, and the Tejas Mk.1A was publicly displayed for the first time during an airshow in that same month. As of March 2025, using remaining engines from the base variant, 3 Mk.1A fighters had been built. It's expected that 11 Mk.1A aircraft will be produced and delivered by the end of 2025, although that still depends on the pace of engine deliveries. With planned production rates of 16 to 24 aircraft per year, all 83 Mk.1A units are expected to be delivered by 2030-2031. To better understand long-term logistics, with a typical aircraft lifespan of 40 years, each jet requires 3 to 4 engines over its service life. 1 initially installed, 1 mid-life replacement, 1 near the end of service or as a spare. Given India's goal of having a fleet of around 200 Tejas aircraft of all variants, the total engine requirement is estimated at 600 to 700 engines. This renewed need has also brought the indigenous Kaveri engine project back to life, now rebranded as Kaveri 2.0. While it likely won't power the Mk.1A, it is being seriously considered for the future Mk.2 version, and development is underway. Now, approximately 50% of its components are manufactured in India. The goal is to further increase this percentage with the Mk.2. In total, around 40 components have been upgraded compared to the Mk.1. This version is now compatible with Israeli missiles such as Derby and Python 5. India has already procured several hundred of these missiles for the Tejas program. Another version currently under active development is the Tejas Mk.2. This variant is expected to be larger in size and significantly more advanced than both previous versions. The cockpit will be redesigned. Instead of multiple displays, it will feature a single large multifunction screen for a more modern, streamlined interface. India plans to equip the Mk.2 with the General Electric F414GE IN-6 engine, offering a thrust of 10,000 kg force. As previously mentioned, India still hopes to eventually replace it with its own engine, Kaveri 2.0. This version will have more hardpoints and be capable of carrying up to 6.5 tons of payload. A carrier-based variant is also being planned based on the Mk.2 platform. Performance-wise, the Mk.2 is projected to reach speeds of Mach 1.8 and operate at a maximum altitude of 17,000 meters. India's ambition is to have 70 to 80% of the aircraft's components produced domestically in this version, significantly reducing dependency on foreign technology. According to optimistic estimates, serial production of the Tejas Mk.2 could begin by 2028-2029. Under more conservative projections, production may not start until 2030. The first prototype flight is planned for 2026, but given the complexity of the program, delays are very possible. In terms of cost, the Tejas Mk.1A is currently valued between $30 to $40 million per unit. There is already interest from several Asian countries looking to acquire the aircraft. Well, that concludes our overview of the Indian light fighter jet Tejas. I hope you found this video interesting and informative. Don't forget to subscribe to the channel and hit the like button. That's all for now. Wishing you clear skies. Goodbye.